Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Functional Programming Principles. Our guest speaker today is Prateek Jain. He is Senior Associate Platform, Sapient Consulting. Prateek has over 8 years of rich cross-functional experience in designing and developing enterprise applications in the financial and telecom domain. He is an active contributor to open source and an avid blogger. Prateek is a certified architect for enterprise application from Sun Microsystems. Apart from regular Java JEE application development, he likes to explore technologies in low latency and the big data space like reactive programming, in memory grids, NoSQL databases. So without further delay, I introduce you all to our guest speaker. Over to you, Prateek.
Thanks a lot. Hi guys, as you know, I'm Prateek Jain and I work for Sapient Consulting, and today I'm here to present some of my views on functional programming languages. In recent time, we have seen a lot of work that is getting onto functional programming space. In fact, lots of languages like Java 8 and .NET are also including these principles into them. So I thought it's worth that we spend some time in covering at least some principle side. What exactly do we mean by functional programming and functional programming principles? So I'll be covering that in today's session. One of the key things that I want to make, I just wanted to clarify in the beginning of this session is, don't expect too much of code. I don't think that one can become expert of any kind of language within 1 hour or 1.5 hour session. So the key takeaways from this session would be that you understand what functional programming is, their principles, and why Sapient Global Market is pitching in this space. So it's like for a developer, from a developer's perspective, I can say it will give me a toolbox which is bigger than object-oriented programming space, or you can, in other words, you can say a developer can expect that his toolbox to solve any particular issue in day-to-day life, he'll be having a lot more solutions in his hand, in his toolbox to solve those problems. So with that expectation in mind, I'm going to start my presentation for today. Okay, let's get started then. So here's the agenda of today's session. So we'll be covering like how object-oriented paradigm that actually serviced us for more than 30 years now, how is that is no longer actually a silver bullet now. Then we'll be covering why we are talking about functional programming here. Then we'll be covering what is functional programming. Then we'll try to have a small comparison of functional programming versus other paradigms. Then what it really means for software engineers or developers. And then what are the cautions that needs to be taken before we actually go and apply functional programming principles to our projects. Then we'll be taking up Scala as a language, and we'll try to cover how Scala is more suitable for Sapient Global Markets, and then how Scala actually implements all those principles that we will discuss in the first half of this presentation. And then we'll try to cover up, take up some questions and feedback. And feel free, in case you have any questions, just feel free to just type in the window, and I'll try to take them up on the fly, or maybe like at the end of this session. So that's it from my side. Okay. So is OOPS really an OOPS? So something that we all are working on, object-oriented programming. So it's suddenly like has no longer been a silver bullet. Some of the problems that we have seen in our day-to-day life are the null pointer problems. On day-to-day basis, we face null pointer exceptions. Then we try to fix them up. If this is not equal to null, then only do this. But there's nothing like a language level support that is provided to us. In fact, the creator of the concept of null himself calls it a billion-dollar mistake because it takes away so much of time from developers on day-to-day basis. We waste a lot of time in debugging these issues, what actually has gone null. So, and there is no language level construct that is available right now, at least in Java or .NET like languages, via which we can overcome these problems. Then we have inheritance related issues. So one of the key problems that I actually face when I go to any project is to understand the domain model. So the way I look at this problem is we start implementing a project and we try to understand the domain model of that application fully. Once we understand it fully, then we will try to use, then there will be a complex, very complex domain model that will derive, because in object-oriented language, inheritance is one of the pillars, core pillars of it. And you would have came across the code where inheritance is being used just to reuse a function or two functions, whereas that is not the intent of inheritance. We all know, like, there are theories like Liskin of substitution principle. So whenever we apply inheritance, there has to be a reason behind it. It should not be used for reusing the code. There are other ways of reusing the code, like composition. Other than this, inheritance has got serious implications when we actually get into the distributed programming or grid programming. For example, issues related to inheritance. If our domain model is actually serialized, now in case we want to change anything in future, we can't, because those objects are already serialized and people are using it somewhere. It is going to break down the earlier implementations of them. So inheritance is actually an issue. Then new operator issues. So we all know that there are very popular frameworks like Spring Framework, and Google's Goose is there, which actually solves this problem. But the main point over here is that every time I do a new and to create an object, this is problematic because I'm actually binding a concrete implementation. And what is the side effect of this using new? The testability of my project, actually I make it very hard, because now I'm having concrete implementations. So in case I need to test my trade object, which is actually a complicated object, if I want to test it and I have used somewhere in my code new my trade object, if I have done anything like that, I cannot mock that object very simply. So that's an hindrance. So the point I'm trying to make over here is that there are some issues, these are very common issues. I'll try to cover up some more issues during the presentation, but these are very code level and very core issues which object-oriented programming is not able to cover up. There are turnarounds to cover up those issues, but language level support, it doesn't provide anything like that. Okay, so now we'll be covering why functional programming right now. Okay, today why are we talking about functional programming? So before I start explaining my points, one of the core points which I would like to ask you over here is the problems that were prevalent maybe like 20 or 30 years back. We are not facing the same problems right now. Let's take up an example. Modern programmers actually face a problem like big data, or there's a huge explosion of data, or we want to have real-time analytics. Business intelligence is there. There are complicated algorithms that we need to learn and provide solutions on fly, maybe extremely at runtime, right? Applications are being benchmarked on microseconds difference. So these kind of problems were not there. These kind of benchmarks were not there earlier. Today, if I talk about say leave the financial background, But even if I talk about e-commerce, the kind of data that is being captured right now is we are just not capturing only the transactional data, but also each and every click which the user is doing on my website, and that data is shared across different applications, and there are various applications that are going through it and giving us various different kinds of results, suggestions, and everything. So that was not there. So the breed of problems that we are facing right now is different from the breed of problems that we were facing like maybe 20 years back. So the problem itself has changed. So the solution also needs to be a bit modified for this. So for giving it, I tried to actually break it down to some of the points which could make sense to developers. So my first point is I have to be good at writing concurrent programs. So the necessity actually of writing a concurrent program or doing multi-threading in my code. I wasn't writing multi-threaded code too much on day-to-day basis 5 years back. But now if I see, I write multi-threaded code on daily basis. So the developers now have to be really smart, and they have to write concurrent this multi-threaded code on day-to-day basis. Maybe like every module that they are developing, it has to be multi-threaded safe, it has to be parallel, it has to be distributed. So these things. So the point I'm trying to make over here is that the proficiency that we need in writing concurrent programs has become a necessity now. Most programs are just sorry, data management problems. So if we talk about big data problems, so big data problems, we can say that is 99% of the time we are dealing with the non-transactional data. So we actually don't need transactions which are slowing us down. So do we really need a transaction-based system, or do we actually need that kind of complex class hierarchy domains that we actually have ORMs built for? So for example, Hibernate has got its own implications. Every time we have such middle layer into our application, we always try to avoid some of the key issues, and it has got some performance problems also. The thing over here is, if my data is going to grow and I'm dealing with problems like big data, Hibernate and other ORM solutions are not a perfect fit over there. So we need to have some kind of mechanism where we can get the similar kind of processing, but we don't want to have costly solutions like object relational mapping in our application. More modular programs. Okay. So more modular. So functional programming actually enables us to write more and more modular programs. I would say it's a return to simplicity, but writing simple programs is not that simple. There are a lot of technicalities that are involved, which I'll try to cover up as we move on with this webinar. So I'll try to cover up like how functional programming actually makes our code more and more modular. I have to work faster and faster. I hope now you can see my screen. Great, okay, yeah. So I have to work faster and faster. So right today, if we say we started up with waterfall model, then we moved on to agile, and now then some years back the concept of Scrum came in, and now we are doing Scrum of Scrums. The point over here is every day our release cycles are getting shorter and shorter. Developers and project managers and architects are facing the pressure that they have to deliver maybe on almost daily basis. Something has to be available for QA. They have to test it, and the key thing is when we started up this session, we said that any application that we start with, there was an assumption that we need to understand the domain model fully. But now we are saying when we have to work faster and faster on day-to-day basis, uh, the understanding, the faithful understanding of that domain model itself has got its suspectance, because requirements and data models changing day by day. So the programming language that we need has to be very flexible, that in case something needs to be changed, we should be able to change it quickly, very quickly. So the turnaround time for a change should be minimized. We try to cover up like how we can do it, but these are some of the just benefits that we are trying to cover right now, that if we apply functional programming principles, these are some of the benefits that we are going to have. The last point that we have in this slide is code is written once but read many times. So we all know, like, applications are there, they go through they go through this development phase for maybe like 1 year or 2 years, and for the rest of the time there's a long maintenance period, and bugs are fixed, some small changes do come in, and people have to like just go back, change something. So the point over here is that once the code is written, it is read many times, that it has to be more maintainable. So if you look at these last third, fourth and fifth point, they are actually converging to a point where they are saying we have to work faster, and we can't compromise on the quality of the product code basically that we are writing. It has to be more modular, because we have to be more agile. We have to understand the problem very quickly. If I'm new to some project and the project is already running, it has got some code base, I'm new, I have to understand it quickly. I will be able to understand it quickly if it is modular, it is more readable. That means we need more maintainable systems now. So that's what functional programming enables. Okay. Now, what is functional programming, right? Great. Okay. I have tried these by looking. Just don't estimate that if we follow, these are the only principles that functional programming has. Functional programming has got a lot more principles, but what I've tried to do right here is just jot down the pillar points of functional programming, right? So the first point is recursion. One of the strongest principle of functional programming is do recursion, don't do loops like for, while, avoid these kind of loops, go for recursion, because that actually reduces the lines of code and it improves maintainability. I'll be showing through these principles through small examples in the coming slides, but this is one of the core pillars, recursion. Then we have got abstraction. Actually this second and third point actually can be combined, abstraction and higher order functions. Basically, higher order functions is a technical term which is used in functional programming that actually enables abstraction. So higher order functions, you can, if you are a Java programmer, then you can think of something like we can pass functions to functions, and functions can actually return functions. So this kind of, I try to take up some very basic examples so that these points actually make sense, start making sense. Okay, one of the very simple example that I have over here is, say we have a list of numbers from 1 to 100, and I just want to subtract each element of this list by 2. So what I can do is I can say al.map x converted into x minus 2. So what it will do is just imagine if we have to do this very basic calculation into the language that we are doing right now, any object-oriented language, it may be .NET, it may be Java. I will have to say list L is equals to new array list, and then for this I is equals to 0, I is less than equal to size, I plus plus, and then I'll make another reference of a list, do this calculation, store every element to this new list, and then so it would be like 8 lines of code that is actually reduced to just 2 lines, and it is much more readable. We can understand it, right? This is one example. I think I have one more example. Yeah. So what if you have to find out the even numbers of from this list of 1 to 100? That's also very simple. L dot filter x modulus 2 should be equal to 0. Then the val evens, actually this evens will be a list of even numbers from the actual list. These are I mean, you can say there could be complex scenarios in projects, but the point over here is the strange thing, especially for the Java programmers, is look at how this the syntax of this L dot map, right? I'm actually passing in a function x minus 2, or you can say this is actually an anonymous function. Like anonymous classes are there, anonymous functions. I'm actually passing some logic over here. Otherwise, I have to create one more method, and then I have to pass it, refer it, those kind of things. So this is simple. These are simple examples, but for more complex examples, also these functions work. So these are 2 examples of like higher order functions where functions can be passed as parameters to other functions. Okay, on this slide, like we are trying to cover up some of the theoretical background about the because functional programming is having its roots from algebra that we studied in our school and degree colleges. So from there, it derives its roots, and we'll try to just give up a very small theory about it, and so that we can understand what is the you can say mindset behind all these principles. So program is actually a description of a specific computation. Y is equals to f of x, and function f is something like x is for function x. F, if we supply x, it is getting converted to y. So this is how we talk when we talk about algebra, right? And in mathematics, we only have variables and actual values. That means in mathematics, we only deal with the constants, and there is no memory allocation concept. While dealing with algebra, if we write x is equals to 3, so in the entire computation, wherever we need 3, we can refer it via x, and in that whole formulation, we never write x is equals to x plus 1 or x is equals to x plus 3. We don't do that, right? Because we don't have the concepts of memory where this x, somewhere in our memory x is located, which actually refers to the value 3, and if I have to change its value, I can go to that memory pointer and change its value to 4, and if I refer x next time, it would be 4. So there is no concept like that, right? And the power it brings on the table, at least from the theoretical perspective, is I can have infinite sets because I don't have to care about memory. I can have a number, like I can try to simulate something like limit x tends to infinity. So I can deal with infinite sets. So those kind of things. Exactly. So maybe like when we talk about computers, then we have to think about memory. But like if we talk about mathematics, we don't have such concepts. And okay, so the next concept actually like talks about the same thing which I was trying to explain. Imperative languages like Java, .NET right now, their variables are actually equal to memory locations plus values. So x is equals to 3 means there is some memory location which points to 3, and x is just a reference to it. Go and update that memory reference, and then you can, if you refer x, you will get 4, and that's where the whole problem starts creeping up, because when I'm talking about memory, it's updation. I mean, there are things that are modified. I'm getting into things like reader-writer problem, producer-consumer problem. Those kind of issues start creeping up. Okay. Okay, great. Okay. So some more theoretical concepts on it. No loops but recursion. No variables except as name for a variable. So we just don't have something like x is equals to x plus 1. Okay, my next point is saying that. So we don't have these kind of mutations in our code, x is equals to x plus 3 or x plus plus. So by principle, functional programming doesn't have anything like this. Only constant parameters and values. That's all we deal about. These are some of the very theoretical concepts. We need to grasp them. And in the coming slides, I'll be having examples of it. What are the repercussions, what it means, and how does our day-to-day problems are getting affected by these principles. If we follow these principles, how do we get all that we discussed in earlier slides? So that is what we are going to discuss in next slides. Okay, yeah. So I hope you all can see a very basic example of this. So on the left hand side of the screen, you can see there is a code for calculating GCD. It's a code from C++, and you can see how it goes in Y, T, Z. There are some assignments, and there are whiles. Then there is a loop based upon a condition, and then we have got we will perform some steps. So this is imperative style. If you look at the right hand side of the screen, there is a functional style of writing solving the same problem, right? And if you see how concise it is, right? If this is equal to 0, return this, else. What is the principle that we are following over here? Just one principle, recursion. We are not assigning anything. So this is a better maintainable solution than the left hand side, at least from my side. I mean, people may differ, but this is something which I feel. Okay. Okay, next slide, functional programming versus others. So we are trying to just have a comparison of what functional programming says and what other programming paradigms are saying. First thing, recursions instead of, are you guys able to hear me properly now?
Yes, Pratik, you are audible. You can continue.
Okay. Great. Okay. So functional programming versus others. So we're trying to just have a small comparison between other paradigms and what functional programming is saying to us. So recursions instead of loops. Don't use while and for loops. Use recursions. In fact, like some of the programming languages like Java and .NET, they have got for each loops where they try to minimize mutations. So they are also like trying to cover up this principle only. So not exactly recursion, but they are trying to minimize mutations in their own way. So recursion, use recursions instead of loops. Use pattern matching instead of if. Use pattern matching instead of state machines. So I'm assuming that people know what do we mean by pattern matching over here. It shouldn't be confused with what pattern matching we have in languages like Perl and Python, percentage, underscore, dollars, not those kinds, but you can imagine it something like a switch statement. So instead of having if and nested if statements, go for pattern matching, and functional programming languages have got support for it, and they are far more powerful than the switch statements that we have in Java and .NET. Okay. The last point that we have is it says information transformation instead of sequence of tasks. So it says it shouldn't be imperative style that we are telling compiler do this, then do this, then do this, then do this. But it should be an information transformation directly for us. It helps us to reduce the lines of code by how are we achieving that? By standardizing the code which is actually not meant for our business intelligence. Say for example, if we have to find out the evens from a list, right? We are saying L dot filter x modulus 2 is equals to 0 is actually going to give us another list which contains even numbers from the supplied list. So what we are doing, we have discarded all the boilerplate code that we have to write for this small problem, and that is standardized and it's provided by the language itself. Then we have persistent data structures in functional programming languages, which is not that much present in other language paradigms. I would spend some time in explaining persistent data structures. By persistent data structures, we mean those data structures which always keep a copy of themselves, the original copy of themselves, and it actually helps them in achieving different, you can say, milestones. Some of the milestones which I can refer right now are, say for example, you have a binary tree, or you have some expression which is stored into by the compiler into some data structure, right? And yeah, let's take up a binary tree, and I want to add one more element to it. So if we go by functional programming principles, which says everything is a constant, that means we are referring to immutability also. I'm having a tree which is having 100 elements. If I'm going to add 101 first element, then it is going to create a copy for me. That means the same object is going to get copied, and that would have serious problems on the way my memory is getting utilized. So we need to check that also. Persistent data structures help us in minimizing it because they keep the track of the original data structure plus the modification. So we just get the memory optimizations that we need to have. They are actually present at the compiler level. So we actually should not think about persistent data structures, but this is some of the principles that we should know when we are studying about functional programming. Functional powerful concurrency constructs are present over there in terms of the actors model. So their concurrency is based upon the actors model, not the exact thread model. It's an abstraction over thread model that we can use over here. Software transactional memory. Software transactional memory is again something like we all know there are ACID properties. ACID properties are present at the database level, but what if we can get the similar kinds of properties in our application also? So functional programming provides that. It also, we can avoid null statements via some option none pattern, which is present over there. So it also gives us the language level constructs for avoiding null pointer issues. What it really means, immutability is good, no bugs due to nasty side effects. By side effects we mean lesser of, we are not changing the global state, or we are not changing something like if you have a function like update user, it shouldn't be something like you are actually passing that object and that object is getting modified within that function and we are returning that function from there. So those kind of things are not present if we follow functional programming principles. Benefits from concurrency due to all the principles that we have discussed already. No more messy loops, and lazy evaluation means avoid unnecessary computations. So we don't compute anything until and unless it is really required. It can have, I mean, some people can say that it has got its own implications, but this is what is coming from the functional programming principles. Some of the functional programming examples, we have Erlang, Haskell, Clojure, F#, Java 8 has got Project Lambda, Scala is one of them. One of the languages, JVM-based languages which implement this. R and Mathematica are very specialized language which are functional, which can be categorized as functional programming language. Caution. So if we look at yeah, just look at these two examples. So first line, the upper one is a pure functional programming construct, but the next one is a mixed breed, which is slightly imperative and slightly functional. You can see that the next one is actually more readable and more maintainable. So the point I'm trying to make over here is it's not that everything that is covered, that is told by functional programming principles is a silver bullet. It's just a right. It just provides you tools by which you can have you can solve your problems more efficiently. So that's something which I'm trying to show here. I have one more example on similar lines. So again, if you look at the second example, it's more concrete than what we have the first one. So one-liners are not always not better. That's what I'm trying to say. Looking at the adoption, so functional programming adoption is like Facebook is using it in a T-chat application. LinkedIn uses actually Erlang. Twitter, UBS Credit Suisse uses Scala. A lot more players are there. I'll try to cover up when I'll be covering Scala. Okay. So, and that's all with the functional programming principles. Now I'll try to cover Scala and how those principles are getting implemented in Scala, these principles. So before we proceed and give any evidence for Scala, just have a look at this. I mean, what are the reviews? Just read to this slide, and probably like you don't even want to move forward. If you were to pick a language to use today other than Java, it would be Scala. If someone would have shown me programming Scala book, then I would have never created Groovy. No other language on the JVM seems as capable as replacement of Java, blah, blah, blah. These are very strong statements, and now let's see who is telling these. Mr. James Coughlin, James Strachan, Charles Nutter. And the point over here is these are very well-known figures, and they have contributed for other languages, and now this is what they are saying for Scala. Just to showcase the kind of client base Scala has, this is a very small list, but even Citibank and HSBC and other investment banks are also using Scala. The popularity of Scala you can depict from this graph. On the y-axis we are showing GitHub, on the x-axis we are showing Stack Overflow, and you can see Scala here, somewhere here. So it's way above the other languages, and it's trying to close to somewhat like Perl, Java. These are mature languages, and they're trying to cover up. They're trying to match up with these kind of languages. So the kind of popularity it is gaining, that's what we're trying to showcase over here. The job trends, you can see Scala jobs almost tripled last year. The point we're trying to tell over here is manpower. I mean, people are learning Scala because we have openings in market, so we can easily go and hire Scala resources. So what exactly is Scala? You can say it's future Java. It's hybrid language because it's both object-oriented and functional programming. I would say it's actually more object-oriented language than Java, and you can say it's functional by its syntax. So I'll try to cover up some of these things via examples. So don't worry about the things. Scale up and scale out with concurrency or parallelism. It has got all these things like Java util.concurrent that you can use, parallel collections. It has actor model implementation, then the features, data flow, MapReduce frameworks. All these things come by default to you with Scala. So You can utilize them to write better concurrent and parallel programs. Both types of programming you can do. You can do imperative programming. That means line by line, the way you do it usually in Java and .NET or other languages. Line by line we can do that, and functional programming. If we can do things in terms of mathematical computations, avoiding mutable data and other things. So that means like both the options are available to us. So in case we are stuck somewhere in one style, then we can use another style. So it doesn't have that kind of roadblocks for us. Scala is object oriented because primitives are not there. Even if you are writing 1 plus 5, which means int plus int, it actually means integer object dot its plus method and another object is supplied to it. So it's more object oriented. Static methods are attached to singletons because so singletons we can make just by having an object keyword in front of our you can say classes. So language level constructs are provided for singletons that you can rephrase it if you want. Imperative style is provided, so it's Scala can be used as a better Java. This is my statement actually. You might not find it somewhere else. Scala is functional because it transforms data objects instead of mutations. Strong list processing via map, forward, reduce pattern. It's thread safe. It's parallelizable. It's strongly typed. It's statically typed. Can be both interpreted and compiled into bytecode on runtime. It's interoperability with Java. So I mean, we have given a lot of points, but what it actually means is, let's say, let's pick up the third point. It can be interpreted and compiled to bytecode. So we can write small scripts in Scala, which can replace our shell scripts. For that also Scala we can use. And if we want to have bigger applications like our trading platforms or any web application, that also we can convert it into bytecode and we can use it on top of JVM. That means like having a build cycle and models and all those kind of things that also we can have. What is the tool support for Scala? It works fine with most of the IDEs, Eclipse, IntelliJ IDEA, builds fine with Ant, Maven, SBT, REPL is there. Script, you can say that the SQL Explorer for which we have for SQL, so it's REPL, what we call it for Scala. Testing frameworks are available, web frameworks are available, Play and Lift are the most used ones, but if we don't know them, we can also use Struts and Spring. Just one point over here, Lift is amongst the safest web frameworks that are available today in the market. So that's a point to be noted. Actors model, they have got Akka implementation. Akka is the name of one of the very famous framework, and it's widely used in reactive programming when we deal with distributed systems. So Akka is one of the key frameworks that most of the products use right now. Fully interoperable with Java, so all Java code and frameworks can be reused. I would say if stuck, do it in Java. Okay. So why we are pitching for Scala in GM? So there are some characteristics of global market sapient that I'll try to cover out here. Scalability, safe type checker. We need distributed across geographies. Our applications are distributed across geographies. We have lots of legacy applications and lots of data. Lots of SOAP is going on from here to there. We have got investments in JE containers, WebLogic, WebSphere, Sun server, and all those kind of things. Compliance issues are there. What it actually means is we have a lot of infrastructure that is JVM oriented, or we are doing a lot of web services. So we need something. We just can't you can say reinvent the wheel itself on the fly. We need something which is compatible with the kind of problems that we are already having, or the solutions, the investment that we are already having. We need a solution on top of it. So compliance issues actually coming from there only, that we just can't go and use any new tool which is available there in the market. We need something which is from their list. So Scala actually, because it runs on JVM, so every tool that is used there, we can reuse in Scala. Okay. Why Scala and GM global markets? Because it has got lesser lines of code, we get lesser bugs, it's more expressive, it has got a strong community behind it, it is ideal for DSL's domain specific languages. One of the key features that enables that is higher order functions. It's a scalable language, we can use it for writing small scripts like maybe copying files from here to there, deleting, removing files, normal bash scripting that we do, and we can use it for writing bigger trading platforms also. It can be introduced incrementally into the projects and in accounts. It runs on a mature platform like JVM. There's no difference for operations team because everything is running on top of JVM. So everything that they are using, all the tools that they were using, they can reuse those tools now also. Okay, so fast product delivery. I think all these principles that we discussed, they lead to faster product delivery. How to introduce, this is actually my opinion. Actually, this is my personal opinion, so you might differ from it. You can introduce them incrementally. That means get the tool chain working for Scala initially, and by tool chain I mean you instead of directly employing Scala into your applications, you can use them for some small deployment tools. Build up small tools based upon Scala, and then as your teams mature, proceed from there. Start with small new projects, planned implementation. Then there's another strategy which says save the company approach. That means high risk, high gain. Means the new project that you are going to start it right from the scratch from Scala. But this means that you are running into this that because I mean it's a new platform, so we don't know what the kind of problem that we are going to face because you know we all don't have the same level of skills. Some people might find it very easy, some people might find it very difficult. Everyone has got its own learning curve, and the kind of tools that would be available within the organization, they might vary. So that's the kind of thing. Where to introduce, where you want to address scalability issues. If you are dealing with very specific domains, you can have DSLs. Testing integration, black box testing, white box testing, lots of boilerplate code. Actually, if we are having DSLs, then even the business analysts and users can write our test scenarios. We can, and the next thing is like we can actually start replacing our small components within our application by Scala because it runs on top of JVM and it is getting converted into bytecode only. So I mean, for other components, it doesn't make any difference. So one by one component replacement can be done. The type of applications that we can use Scala for they can be web platforms. Lift is an awesome framework. For trading platform and financial modeling also we can use, as we are using core Java, in the same way we can use Scala to come up with our logic. I think that's it from my side. I tried to explain things about Scala, some very basic principles about functional programming, how Scala implements it, and why Sapient Global Markets is actually pitching in for Scala to be used. So these are some of the points, and all this is available on internet, collected from various books and articles, and the implementations that we have done here in Sapient. If you guys have any questions, feel free to ask them.
Pratik, there are many questions from the attendees, so can you please open up the doc and answer them? They would be in your questions doc.
Yeah. Okay, just 1 second.
Yeah. Are you able to access it?
Yes.
All right, you can take them as per your requirement.
I'm just opening it up. Okay. Okay, what is ORM? ORM is object relational mapping. That is used to convert objects to relational model, because database is relational and our applications are object oriented. So the impedance mismatch that we have, so it's a kind of middleware that enables those kind of things, but it actually has got its own implications. We have to use it because we love objects a lot. Okay, which language support for FP? Scala is one of them. .NET already has got F#. Java 8 is going to have core features from functional programming. You can say Scala implementation in terms of closures. Lambda project is there, and there are small other changes that they have done to enable functional programming in Java. So from Java 8 there will be Java people will also be able to have something like multiple inheritance, and you can say anonymous functions and the map flows. I mean the other things that in fact for multi-threading also, Akka, the framework, that is also available for Java developers, so they can use it. Is this Scala? Yes. Can we use this programming style in PHP? Can't comment it right now because I'm actually not sure how does PHP behave. Maybe like I can get back to you on this. But in the end, these programs are going to execute on computers, so the memory will come into picture. Exactly, the memory is going to come into picture, but the point that we're trying to make over here is, say for example, I have 70 objects when I do in my usual ways, right? There are 70 objects that I'm going to create. When this my data is going to bump up from say 1 gigabytes to say 10 gigabytes, I'm okay because I can supply that much memory. But what if when we are talking about big data problem, when we are talking about terabytes of data, won't it help me if I don't have 70 objects, but I'm having a simpler model which is maybe having like 40 or 50 objects, and the interdependence among them is lesser, and they are not mutating each other. So the multi-threaded program that I'm going to run on it, it can take the advantage of the more modern different cores of my processor. That's the point I was trying to make here. Why Java doesn't support multiple inheritance? Okay, the person has left, so we can take it up later. But recurrent take memory as normal loop. I didn't get the question. Is it recursion? I assume this is recursion, and I'll try to answer it via that way only. So recursion takes more memory. You are absolutely right. But if you talk about functional programming compilers, modern functional programming compilers, they employ a technique called tail recursion optimization. So that is present there, and it actually overcomes the point that you are trying to make over here, that the stack frames actually going to pile up one above the other. So that thing actually goes away with the tail recursion optimization. Probably you can just go back to once you go back, you can just type in Google what is tail call optimization techniques. That program can go in finite loop if v is equals to 1. I think I can take it after if the time permits. Let me take something which I can answer very quickly. In functional code output, value of a function depends on the arguments. Actually, in functional code output, value of a function depends on the only on the arguments that are input to the function. How is it different from the normal function? So code from output value of a function depends only on the arguments. Okay, input to the function. How is it different from normal function? So the way it is different is, think about this. In normal loops, we cannot have functions supplied to functions. Even if we try to mimic that, we can't return function from a function. So imagine it. Actually, I can give you some detailed example. Let me try to think up about some very small examples. So, say we have to have some kind of Fibonacci series, and I want to have some kind of strategy implemented into it that instead of simple numbers getting added up, there should be some algorithm based upon which those numbers should be added up. Like say every number should be squared before it should be added up. Tomorrow I can say uh, uh, it should be something like a cube that should be there, or any other algorithm. So those algorithms can be changed on fly at runtime. That is the power that it gives you. Could you be so kind to tell us what is pattern matching? I told you, like if you want to just think of it as a switch statement in terms of syntax. But it's in functional programming, it's much more powerful. You can have it on objects and their properties. It's pretty much, I mean, it's much more powerful than what we have in Java and .NET. Sometimes even we call it on the projects that these are switch statements having steroids. Is there, we don't have the memory limit for variables. Is there, we don't have memory limit for variables. I couldn't get this. Memory limit for variables. I couldn't get this. Maybe like after this session, you can send an elaborated question and I'll try to answer this one. How this works for who are C# programmers? What exactly you want to ask? I mean, what exactly works for C# programmers? Because .NET has got a fully functional language called F#, and I don't know, I mean, which particular feature you are trying to ask, that how does it work for C# programmers? Maybe like some more detail can help us. What is the difference between Scala and C#? C# only runs on Microsoft platform, whereas Scala also runs on .NET and JVM. So it can run on both the platforms. And Scala is a pure, you can say, a functional programming language, where C# is not that pure. That's what my .NET friend says. F# is more functional than C#. Can we work on web technologies like Struts, Spring, use Scala? Yes. I think I already answered this question. Hi, so my question is, what is the scope of functional programming in ASP.NET? For that, actually, I need to study ASP.NET. Probably like I can the questions which I'm not answering right now, I can try to reach out to you guys after this session on one-on-one basis. Why Scala instead of Java? I think this whole presentation was about that, because these functions, and I'm actually not saying leave object-oriented programming. In my entire presentation, I haven't said this, and in the initial part, I said for all the developers, knowing functional programming is actually giving you a wider toolbox to solve our day-to-day problems in a much nicer way. So even if we can't have Scala in our projects, use these principles to solve your problems efficiently. And why Scala instead of Java? I think I had DEX along throughout this slide presentation, which says why we should use a functional language rather than a pure object-oriented language. Can you explain GM is all about? So GM is actually Sapient Global Markets. We here are catering investment banks, asset management firms, and other financial clients. So it's actually a company, or you can say a department under Sapient Consulting. Scala can be used on C# and .NET. Scala code can run on that .NET platform also. So that's my answer. Is there any tool is required for Scala? What kind of tool? I think I had a list of tools that all you need in any application. You will need an IDE, compiler, some build tools, some deployment tools, some testing frameworks, some web frameworks, some dependency injection frameworks, all those like I've already listed. So I think this is already answered. What is advantage of Scala over Java? Again, the same question. What is the advantage of having a functional programming language on object-oriented language? But don't say, I mean, I'm not saying any functional programming language is an alternative to object-oriented language. I mean, we need to make a choice when we are solving a problem. That's why like we pitch in for Scala, because it enables us to choose the right tools at the right time. How does this help C# programmers? Again, like it's the principles that you need to use. How to use Scala? Is it? Okay. Probably you might want to go to Google and see. There are various articles. Jokes apart, there are various articles that can give you a kickstart on that. What are the risks involved in adopting Scala? There are risks like some specific kind of problem that you're trying to solve, or you can say in multi-threading you can't have, you run into a bug and you are not able to debug it that frequently. I mean to say you are not able to pinpoint that, because the point over here is it's nothing like Scala is not a mature platform, but the thing over here is that the quality of developers that we are having right now, everyone is not that conversant with Scala as they are with Java. So I can even think about code in Java, but for Scala I need to, first when I was beginning, right, to write code in Scala, I need to stop for some time and then think about the syntax and the kind of principle that I'm going to apply, which exactly thing is it going to be currying or partial order functions, what exactly I'm going to apply. So the risks are actually based upon the capability of the developers and the architects that are available. And maybe like there could be any random problem that might give you sleepless nights. So that can be done, well, that can be at least tried in Java. It's actually the confidence. It's nothing that Scala is risky. So is web programming supported? Yes. Play and Lift are there. Which one of the best functional programming, Java or .NET? Java still has Java 8 will be having some functional programming constructs. So .NET is right now something which is better than at least Java, not the JVM languages, but Java language itself. .NET has got better support for functional programming right now. Does SAP support functional programming? I don't know. Scala is a programming language, yes. And do I need to be a Java programmer to learn Scala? Where I can get training on Scala? Visit the official site of Scala. It has got its training. You can get the training material there. You don't have to be a Java programmer, but it will help if you are having some experience in Java. Can we use Scala in .NET? Yes, you can. Is it possible to do functional programming via function expressions in JavaScript? Yes. What is REPL? REPL is something like a shell script, like you have got SQL Explorer for executing SQLs. So you don't have to, and you get the results on runtime. So REPL is, again, you can say that kind of shell for Scala programming. So if you are writing something and you want to see how it will behave, you can use this REPL. Or if you are having a very small program, say maybe for example some kind of deployment program which is very small, so you can just save it as .scala file, and it will this REPL, it will execute on the fly, so it won't be compiled into bytecode and those kind of things. You don't have to do that. How is Scala different from Java in coding perspective? Syntax is quite different, but both run on JVM. I'm using C# language on .NET, so compared to C# with Scala, which one is better? Uh, I can get back to you on this lately. Why Java not support multiple inheritance? As I said, like Java 8 will be supporting multiple inheritance, but right now it doesn't support because of the diamond problem that we all know. When you write 1 plus 5, it actually means 1 plus 5, is it integer treated an object? Yes, and I think you missed the dot part of it. So one is an object, and then dot is there as you use for objects, and then plus is actually a method which is expecting integer. So everything is an object. There's no concept of primitive types. Difference between Java and Scala. I think I already answered this. How functional programming is different.
Sorry to
from,
interrupt,
yeah.
but Pratik, due to time constraint, I request you to take a couple of questions more, and then you can give a brief to end the session. And I would be sharing the unanswered questions offline with you, which you can answer through email on one-on-one basis.
Okay, so what I'll do is I'll just scan through these questions. If there's something which is more generic, I'll try to answer, and then we can wrap up.
Right, Pratik.
Okay. Please give a simple example. Architecture. Data structures and I think most of the questions are based upon like how we can use Scala, and basically like they're asking like how to start programming in Scala. So my recommendation would be like just go and visit Scala's website. It has step-by-step tutorials, or you can actually we have something internal to Sapient which caters all these problems. But you can definitely just visit Scala's official website, and it has got a lot of documentation over there. And then people are asking about, I mean, how do we compare it with C# and .NET and other features? Probably like it will take up some time, and one of the person is asking us to explain some of things like persistent data structures. So this is something that will take up some time, maybe like one more session to explain persistent data structure. So it's not that simple. I'll try to answer some of these queries on one-on-one basis, and but as the time, because of time constraint, will conclude this session over here. Feel free to send more queries, more questions, and I'll be more than happy to answer them. So my actually conclusion to this webinar is these are good principles. Even if you can't have a full-fledged functional programming language into your project, start thinking about these principles and employ them in any of the language that you are using. They will enable you to achieve all these benefits that we already listed. So this is something for which you don't need a full-fledged language. Employ principles, and wherever necessary, if your project or application permits, try to brush up with functional programming languages like Scala or Haskell or Clojure, whatever suits to your requirements. So with that, I think I'll conclude this session.
I'm really thankful to our guest speaker.
Thanks a lot, guys. Thanks for listening.
Yes, I'm really thankful to our guest, Pratik, for conducting this wonderful webinar today. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. So thank you all for joining us today. Thank you, Pratik, for taking time out for this webinar.
Thanks a lot.
Okay, we close down the webinar for today.